Hey guys, welcome back to the channel. I know we've had a little bit of a long hiatus here. I've actually moved. I'm currently in a different shop while a new, much larger shop is being built as we speak. I'll have some content for that coming up as well, but I see a lot of guys asking about the process in which they buy one of these Langmuir Systems Crossfire tables. They're a pretty popular unit, especially at their price point. It's bringing a lot of people into the market that don't really necessarily know anything about them or necessarily know anything about CNC. So this video is very generic, but it does show how I walk through the process using Fusion, and then I use my my post processor. I'm using SheetCam, and then we go over to the table, pull that up in Fire Control, cut the bracket that's going to make this. I'll talk about this in just a second. And then I also have a Crossfire, or a Langmuir Systems Titan, which is right there, and that is that we'll use that to bend this bracket. So this is not going to be an instruction on how you take measurements to make a bracket like this, right? This is where you use like something like a cardboard template, or take your measurements and kind of set up how you're wanting to make whatever piece you're wanting to make, and then use Fusion to do that. And I'll kind of walk through that pretty briefly in the next segment here. But what we're going to make today is this bracket for my tractor. What this is a bracket that bolts onto the ROPS. There'll be a light that sits on top. There's a square hole because there's a plug that needs to run down through this that goes and plugs into the wire harness. And then there's a place for flashing lights on the front and back. I mowed some roadside that's state roadside, so people are flying down through there. Just kind of give me some visibility when I'm mowing that. So let's kind of walk through how to make this bracket using Fusion. First we're gonna use the sketch. We're gonna create our initial sketch and then use the sheet metal tools to do everything like well, you can see this, see if I can get this to zoom in here, focus. Cut these reliefs on both sides of this, so when you're making these bends, this will turn out the way that you're wanting it to, and then we'll go from there. So let me know if you have any questions. Again, as you watch this video, if you have a question about what I'm doing, put it down in the comments section. I'll do my best to answer those. If you do like this type of content, I have some more things coming. Like I said, it was kind of a hiatus with COVID, and then things got busy. We built a house and moved, and all this stuff's going on. But now what I'm trying to do is get back into making some content. I have some things on the horizon I'm wanting to work on and get that stuff filmed. So we'll make this the first new video we've had in a while, and let's get started. All right, so this part of the tutorial is not necessarily to show you how I came to these measurements, but really to show you how I created this part in CAM, how I exported into DXF. Next we'll go into SheetCam, but kind of show you how I use the sheet metal tools within Fusion to create this. So we're going to back this up on the timeline all the way to the beginning, and then we'll turn on that first sketch. And what this is, for this particular part, it's a light mount for a ROPS on a tractor. I basically drew out where the hole needed to be for the light mount, and also where there's a little square where the electrical connector needs to run down through, and that was my first piece. You'll draw this in just a standard sketch menu. You don't want to extrude anything here. You're going to want to take this drawing, go over here to the sheet metal menu, and then go up here to the top left and say create flange. Now you're going to want to create a flange out of this first drawing. There's plenty of tutorials out there on YouTube now on how to set up your sheet metal rules, but you're going to want to do that prior to doing this part of this so that you can make sure that your rules are set correctly. For instance, you'll see over here on the left hand side, this is drawn currently with a 14 gauge sheet metal rule. I have a bunch of these: 14 gauge, 16 gauge, 12 gauge, 1/8 inch, 1/4 inch. So anytime I'm doing anything like this within the sheet metal options, trying to figure things out, I can use those sheet metal rules that already has all of the thicknesses and stuff in place. So I'm not going to redo that because otherwise it'll mess my drawing up. But you'll see here, the first thing on the timeline was I went up here, I went to sheet metal, create flange, and when you do that, added the 14 gauge sheet metal rule, this is what I come up with. And at this point, this first sketch, you can turn it off, and that's the top of the light mount. From here in the sheet metal options, you can see there's all these little angles, or these little edges right here on the bottom side of my part. This is where you're going to want to create a flange. Anytime you want to create a flange in the sheet metal rules, you just click on the whichever bottom side or top side you want to add a bend to, and you go up here to create flange, and you can say what your length is. You can change the angle to whatever you want here, and it's going to go through and do all that stuff for you. I'm going to cancel that because this is already done, but that gives you an idea of the sheet metal tools, and I can do an in-depth sheet metal drawing later on if you guys would like to see that. So from here, we'll go to the next thing. You'll see this is where the mount goes for the side of the ROPS. And this is the beginning of it, because here you'll see down here on the timeline, I created another sketch here. This gave me the angles of the ROPS, where the bolt locations needed to be. You'll see that I don't, in my personal experience, a lot of times I will create 2 holes if I'm dead nuts on and know exactly where I'm going with the holes. Sometimes with things like this, these holes are, they'll be off one little bit one way or another, so I usually create a slot in one of those just to make it a little bit easier to mount. And if it's not some imperative part, it makes it a little bit easier. From here, with this, I extruded off the back side, so I chopped off the back side of this and then added and then removed the holes and then added the front side. So what that did was gave me the angle you'll see here. We'll turn the sketch off, and that's the angle of the ROPS where the holes go, in conjunction with where the top of the light needs to be. Let's see here. Now, next, I created another flange over here on the front side. So I did add some additional emergency lighting. I do a lot of roadside mowing, so the most amount of lights I can get to be visible, the better. So I put some additional flashing lights on this light mount on the front and on the back. And then from here, I did the same thing I did over here on the right hand side. I just created a sketch, which I will turn on, and this is basically where the wires come through for the lighting, and then the little bolt holes for me to mount those to. And you'll see those are slots again. I had the center drawings, but with plasma, everything isn't always really super accurate, and these are small holes, so I figured this would give me the opportunity to be able to put the things in and line it up perfect on the front of this so that it's centered, and then tighten everything down. Next thing I did was I extruded that all the way through. So I wanted those lights to be perpendicular to one another, so when I extruded this, you can see here it actually extruded through both sides so that I know that those are dead even with one another. We can go ahead and turn that drawing off, and then from here I just did some changes, and you'll see I'll march through this. There's like a little chamfer on each one of the things on the light, so I just added a little chamfer on the bottom side of this just to make it kind of look good. The next thing I did was added some rounded sides on the side of the ROPS section. Again, not necessary, but if I can make something look better, I'm going to. And then to cover up my bolt holes and provide a little bit of additional strength out here on the outside, I just added a flange out here on the outside, which would cover the bolts and kind of cover up all that stuff that's underneath there so you don't see it once it's mounted. So from here, with Fusion, this is in the sheet metal stuff, so you might be thinking, how in the world do I take this and turn it into something on my plasma? In the sheet metal menu, you're going to want to go up here and say create a flat pattern, and what this is going to do, as you can see from the menu, it's going to take whatever you're making and flatten it out so that you can get your bends. Now this will also help if you're using, like I use a Titan brake, but no matter what kind of brake you're using, it'll tell you what your dimensions need to be to get your bends in the right place, stuff like that. You can take measurements out of Fusion that way and create your bend patterns. And so from here, I'll create that flat pattern. I usually use the first face. You can use whatever face you want, but in most situations, I use that first face as my stationary face. And what that does is it folds everything out from there. You click OK, it automatically folds everything out for you. In the flat pattern, this middle line here, for instance, from this middle line to this outside, if you wanted to look, you can say inspect from here to here. It'll tell you that's 1.309. That's what you could program your bender to, or take your measurements from, so that you know that your bend is in the correct place every single time that you do your bend, or in this case, just when you go to make your bend. What else is there here? I think that's it. So you'll hit close. You can hit finish flat pattern. It takes you back to your part. When you're ready and you're like, okay, this thing's ready to go, you can go back up here and activate your flat pattern, and then you can just say export DXF and say okay. I'm just going to call it light mount. That's it. Now you have your DXF. You can take and import this into SheetCam, which we're going to get to next to create your G-code. So the next part of this is going to be bringing the part into SheetCam. We'll talk through this a little bit, but if you're a current Fusion user, you're going to see why most people prefer SheetCam that do plasma work. And really that's just because the ease of creating your cut paths here. You're not clicking on any profiles and making sure you're on the right side of the line. It's literally just pulling it in your object, your DXF file, selecting your cut operation, whether your interior or your outside profiles, and you're done. So we'll start with bringing in the file. So it was called light mount. This is the file that we just flattened out in our part in Fusion. You could see here that the red right here is your exterior profiles. All these little red circles, the ones that have plus signs in the middle of them, are perfect circles, and then you see my little ovals that we drew in. Excuse me. And then these other lines that are here are the middle one of these. So you have your outside bend profiles, but the middle line is where your bend is going to be in each one of these. So first things first, we're going to create an operation. We're going to do all of the inside profiles. You could pick interior profiles. I already have my sheet metal rule set up here for 14 gauge mild steel with a fine cut consumable, and it's done. It automatically goes through and does these. Now, actually I need to change this because I have no lead out on those. So you can see it was that quick to just go through and set my interior profiles up. The exterior profiles are just as easy. The outside profiles will go outside offset, outer profile, hit OK. There's our cut file. I mean, we literally can go through and export this right now and be done. If you notice, it did skip over our bend lines, which is fine. But now all I have to do here is hit save G code. I'm going to leave this named light mount since I know that's what it is. I'll hit save, and it's done. It's ready to pull into fire control. The next thing, though, before I go down to the plasma table, I want to create a spec page for our bends. So I'm going to jump back into Fusion and do that real quick, and then I can print that out and take it down to the bender with me. So we jump back in here in Fusion real quick. We're going to jump back over to the flat pattern, which you can activate the flat pattern up here in the navigation pane. And then what we're going to want to do here is create a drawing from this design. So it's going to have it selected here. I want sheet size A, I think, is 8.5 by 11. Yep. And then you're just going to hit OK. And what this is going to do is it's going to create, in just a second, it's going to create your drawings page here. So I'm going to make this 1 to 1.5. Let's see if that might be able to make it 1 to 1 on this page. No, let's go to like 1.25. Okay, yep, that works. So we're going to place that. We're going to say OK. And now what we're doing is we're going to just take some measurements and put it on the page. And then that will let me know when I go to program the bender, or if you're using a manual bender and you want to take measurements here and then mark these with a scribe so that you know exactly where those are going to be. So I just use the auto dimension function here. We're going to click the bend line, which is the one in the middle. This top line, we know that's 1.31 inches. And then from this bend line to the edge here is going to be 3.68 inches. I know that, I know that this one is the same as the top, so this is, drag that down, 1.03 inches, and then like I said, from here to here, it's 1.31, so I wouldn't do anything there. And now I could take this down to the bender, or I can take this page, I'll print it out, take this page down with me, and like I said, or my Titan, I can just program each one of these bends in, so I know exactly where the middle of the bend needs to be, and then we can go from there. So that's creating the bend sheet. I'll print this out. Next up is going to be cutting all this out on the plasma table. All right, so now comes the easy part. I've opened up fire control over here on the PC on the XR. I've loaded a piece of metal. I think I found a spot over here in this bottom corner that I can use. We're going to import the file. Should set it in what I had set as my home position. So that's down here. That's that corner down there in the metal. And I got the hypertherm turned on and we're ready to go. So at this point, put the ground clamp on the piece of metal. Everything's lined up. The hypertherm's turned on and we just got to hit start. Alright, so pulled it out, there's the part. Next thing is cleaning, right? So plasma cut, you're always going to have dross and stuff like that. I found the best thing to clean them with is an angle grinder with a cut brush on the end of it. But I'll get this all cleaned up and then we'll be on to bending. Alright, so now we're going to take this piece, use our printout that we made earlier. I got the bender program for this, and I have our dies in place. So what I'm going to do is, before I put you on the tripod, I've already set up where the back gauge, we can run this side, the back gauge needs to sit. And so what that'll do is, when you slide the material in, it'll slide in and stop against that back gauge so that you're in the same spot every single time. What we're going to do is we're going to bend both outsides of this first. And then we're going to bend this one, and then this one will be the last one, this long one. So I'll put you on the tripod and we'll get this all bent up. Went the other way. Barely touched, but it did bend it a little bit, so I'm gonna have to fix that one. That should have technically went on the inside here, and then would have cleared against this this gooseneck die. So that's lesson learned there. But next we're gonna bend this one, and then we're gonna bend that one. Alright, so I was able to get those lined back up in there and get them bent back to 90 degrees. Now we're going to bend this bottom tab. I went ahead and changed my program, which brought the backstop up a little closer. And you can see I used dies that will allow clearance for this in here. So we'll get this lined up. There's the outside. Now we're going to bend this tab down here, and I think we'll be in business. So I'll get that program changed and then we'll bend this one. All right, so I got my program changed. We're gonna go ahead and we're gonna run it. You see the back gauge move to where it's supposed to go. We'll get this slid in here, put my glove back on here. We're gonna slide this in place. This one's gonna be pretty imperative because we have to make sure this is lined up on here. Go ahead and drop the ram. And looks like about right there. And go ahead and bend it. And I added another retraction here, I think of about 1.5 inches, which should clear all of this so I can get this bracket out of here. And there's our bracket that we drew up in Fusion. So I'll test fit it and we'll see how it looks. All right, so I test fitted the lights on the front and the back. I test fitted what will be the floodlight that goes on the top of the ROPS. That's the hole where this big plug here can slide through. I'm probably going to 3D print some guards that go around the inside of that just to keep the cable from rubbing on metal. But that's it. So everything worked out. Everything looks good. It's exactly what I was looking for. And that gives you an idea how, you know, what my workflow is to create and design. I guess I could say just really create a piece like this from a design that I've kind of figured out. So if you have any questions, let me know. Leave a comment down below. And if you'd like to see other video or other content like this, let me know and I can set something up. All right, thanks.